So I would like first to thank Jesper Gunst, our speaker today, for accepting to be the inaugural speaker for this new series of webinars that we are organizing in the context of the Rhiviera consortium. We will try to have these webinars periodically, at least 4 or 5 times a year, and we will send you the schedule with the next webinars in the next few weeks, I hope. So if you have any question for Jesper, please raise your hand at the end of the webinar, and we will be able to open your, or to give you access to the mic and open it and ask your question directly. So Jesper, thank you for joining and accepting to share your results with us. Jesper is an associate professor at Aarhus University in Denmark. He's an MD, PhD, and as you may know, he has been involved in some of the main clinical trials exploring immunotherapies for HIV remission, at least the most innovative, I will say, in the last few years. Most of them including treatment interruption, some of them including broadly neutralizing antibodies, and he and with other colleagues, they have done a meta-analysis of multiple studies with treatment interruption that has been developed in the last few years, and which provides a very useful tool for all of us interested in this immunotherapies seeking HIV remission or post-treatment control. And so, well, we are very happy to have you with us today, and eager to hear to your presentation. Thank you, Jesper.
Thank you, Asier, and good evening, everyone. I tried to focus this presentation so that it would fit with the consortium. And we chose the title, Without Intervention, Time to Viremia and Frequency of Post-Treatment Control After ART Interruption. So I'm currently in a clinical postdoc position at the Department of Infectious Disease in Aarhus, and it's funded by an unrestricted grant from the Lundbeck Foundation. The agenda for this evening is a little background, then our data on individuals that received either placebo or no intervention prior to stopping antiretroviral therapy, ART, during an analytical treatment interruption, an ATI. And we mainly focused on time to viremia, but we actually did this meta-analysis primarily to find what's the frequency of post-treatment control, the PTC. Lastly, I have a bit of a perspective on post-interventional control, and with focus on these broadly neutralizing anti-HIV antibody called BNAbs. The presentation is based on this paper that we published recently in Nature Communication. I just told you that our main focus was the frequency of post-treatment control, and I look at it a little bit like, where's Waldo? So we really wanted to know what's the frequency of this post-treatment control. We know that ART reduces the HIV reservoir. So beyond 4 years, the size of the reservoir is more or less stable. Most of the HIV DNA that's integrated into the genome of the cell is defective, but it may still be a source of low-grade inflammation. The lifespan of these resting CD4 memory T cells is years, so they stay in the body lifelong. Homeostatic proliferation, here shown as the colors. Homeostatic proliferation of the T cell is like the main driver of persistence of the HIV reservoir. We know that if you start art early, you limit the reservoir so that the size of the reservoir is lower compared to when you start art at a later time point. Other benefits of early art here, if you look at the left side, it's from the Caprisa cohort. It's an individual that's followed 6 years after HIV acquisition, and you can see that after 1 year, the viral diversity, and then after 6 years. So looking at the right side, the longer time from HIV acquisition to art initiation, the higher the viral diversity of the reservoir. And the same accounts for immune dysfunction. The longer time from HIV acquisition to art initiation, the higher the immune dysfunction. Art effectively blocks HIV replication, here shown as plasma viral load at the y-axis and time on the x-axis, and the virus shown in blue. So once art is initiated, the viral load declines to below limit of detection. But if art is paused again, art is no cure, and eventually virus will rebound to pre-treatment levels within the weeks. But there are 3 categories of HIV controllers. The first one is like the spontaneous or the elite controllers. These are individuals that have never received ART, and they can control for years to decades. These individuals are characterized by having specific protective HLA types, and the frequency of these individuals is below 1% of people living with HIV. The second group is the post-treatment controllers. These people have medium to high viremia prior to starting ART. They then are starting on art and suppress viremia for a period of time, and then at some time point stop ART and can control viremia for months to years. And again, I must highlight your landmark study from Asier's group, the Visconti cohort. The third group is the post-intervention controllers, and it's a small group, but it's also characterized by medium to high viremia prior to starting ART, suppressed on art, and received some sort of medical intervention during the trial, and can control from months to years after stopping ART. We did this meta-analysis, and it was an individual participant-based data meta-analysis. We did a literature review using PubMed, and we include the studies based on the following 4 criteria. It had to be a prospective clinical ATI study. It had to involve adults. The intervention should either be placebo or no active intervention, so just pausing ART. And there needed to be a frequent plasma viral load monitoring, and we defined it as a minimum of 5 planned plasma viral loads within the first 84 days or 12 weeks post-ATI, with a maximum of 18 days between plasma viral load within the first half of the period. Shown on the right is how many articles we identified, how many we screened, and we ended up with including 22 that was published in peer-review journals and 2 that's not published yet, and it's shown here. But actually one of the unpublished was just published last week, the ALEX 003 study. Just a brief description of the studies. So 14 of them were randomized controlled trials, RCTs. 10 were single-armed ATI studies. 13 of them were undertaken in the northern part of Europe, and 11 were undertaken in the northern America. Art restart criteria in the studies were based mainly upon plasma viral load and CD4 T cell count, but they're differed on the exact threshold. I have just during the presentation highlighted where in our paper that you can find more specific information about this. And and look it up perhaps later. We had 382 study participants, mainly male participants, mainly white. The median age was 42. At art initiation, the median CD4 T cell count was 422. The median plasma viral load was almost 50,000 copies per ml. At the time of ATI start, the median CD4 T cell count had increased to 781. And at ATI start, almost half of the individuals were on integrase strand transfer inhibitor-based regime. 18% were on NNRTIs, and 34% were on protease inhibitor-based regime. We made some definitions in the study. We had the definition of early art, defined as individuals that were starting on art within 6 months of acquisition, and there were 44% of these individuals. Late art was defined as art started beyond 6 months of HIV acquisition, and that's 51% of the individuals. These definitions of late and early art were based upon test results, antibody, antigen, or recency testing, but also based on self-reported. A few of the individuals had unknown date of HIV acquisition and were categorized as unknown. NNRTIs impacts time to viremia. And it just said that 17% of the individuals were on NNRTI at the ATI start. And NNRTI as a drug has a longer half-life compared to the other art drugs, so there is a drug tail into the ATI. We did this Cox proportional hazard model looking at risk factors for time to viremia above 50 copies per ml. We looked at sex, late or early, or NNRTI or not, and you could see that NNRTI was a risk factor for longer time to reaching above 50 copies per ml, and this was in an unadjusted model. We then did the same adjusted, and again NNRTI was associated with longer time to reaching the criteria of viremia above 50 copies. So individuals that were on NNRTI, we omitted them from the analysis of time to viremia, but we included them in the overall analysis of the frequency of post-treatment control. Here's the viral kinetic rebounds of the 382 individuals, and it's difficult to see, but most of the individuals follow a similar pattern of viral rebound. The median time to reach plasma viral load above 50 copies per ml was 16 days. And this was only for the individuals on the non-NNRTI. It's important to highlight that after 84 days or 12 weeks of ATI, only 4% had below 50 copies per ml. This is shown in another way, that in green are the percentages of individuals with below 50 copies per ml, and in red or pink are the proportion of individuals with plasma viral load above 50 copies per ml. We did the same approach, but divided individuals into whether they were early art or late art. And we could see that after 84 days of ATI or 12 weeks, there were like just in total 4%, but if we divide them into early or late, there were 6% post-treatment, or 6% that had below 50 copies per ml, 6% among the early art individuals, and 1% among the late art individuals. And if we do it as a time to event analysis, so this is the individuals that has so 100% at time 0 has below 50 copies per ml, and along time, more individuals have a plasma viral load or reach a plasma viral load above 50 copies per ml, but you can see that there is a statistical significant difference between time to reach above 50 copies, whether you were started on early art, that's 19 days, or late art, that's 15 days. So it is statistical significant, but not clinically significant, I would say. We also looked at factors associated with time to viremia, and here is a heat map of the Spearman rank correlation between immunological and biological variables for the ATI participants. So we had pre-art plasma viral load, we had nadir CD4 T cell count, we had CD4 T cell count at ATI start, and then different time points or 3 different criteria for time to viremia: 50 copies per ml, 400 copies per ml, and 10,000 copies per ml. And we also have this variable that we call the initial viral doubling time. I'll get back to that in a minute. When we graphed the nadir CD4 T cell count and the CD4 T cell count at the ATI start, there were significant positive correlation between the two. And also when we graphed nadir CD4 T cell count and time to viremia, there were also a positive correlation, meaning that the lower the nadir, the shorter time to viremia among a participant. This initial viral doubling time was defined based on the first 2 consecutive plasma viral load that increased, and the second plasma viral load had to increase by 1,000 copies compared to the previous. I just showed it here as an example. So if we first look at the green increase in plasma viral load, it's a fast rise in plasma viral load, it's a steep curve. So there's a shorter initial viral doubling time, so the virus doubles during a short period of time. If we look at the purple line instead, there's a slow rise in plasma viral load, it's a flatter curve, so there's a long initial viral doubling time. Why all this information about the initial viral doubling time? So here it's plotted against time to viremia of the threshold of 50 copies per ml, 400 copies per ml, and 10,000 copies per ml. And the higher the threshold gets, the more positive the correlation becomes. And we interpret this as initial viral doubling time perhaps is more a marker of the immune pressure. Post-treatment control, there's several different definitions of post-treatment control, but in this meta-analysis, it was defined as individuals with different plasma viral load threshold, either below 50 copies, below 200, 400, or 1,000 copies at day 84 or the 12 weeks of ATI. So you need to have below this threshold either at the time point or the closest time point to day 84. But if you didn't have a specific measurement at that time point, you needed an additional time point afterwards. We defined post-treatment controllers as either individuals where all the plasma viral loads were below 50 copies per ml as sustained post-treatment controllers, or regained post-treatment controllers that were individuals that prior to day 84 had a measurement above 50 copies per ml. We had this very stringent cutoff of 50 copies per ml because it mirrors the current treatment goals for HIV, and it would also exclude viremic controllers. So here's a graphic of, like, you could call them elite post-treatment controllers that has below 50 copies per ml, or viremic controllers that just harbor between 50 copies, perhaps up to 2,000 copies. In our group, we saw that 4% had below 50 copies per ml at day 84. And that's a total of 14 individuals. That's 4 with sustained post-treatment control and 10 with regained post-treatment control. Among the individuals that regained post-treatment control, 4 had a peak above 50 copies up to 400, and 4 other individuals had a peak above 400 up to 10,000, and 2 individuals had a peak viral load above 10,000. So we could say that the higher peak of the viral load, the lesser the chance of regaining post-treatment control. And it's just shown here in another way. So this is a pie chart showing the 4% of post-treatment controllers at day 84. And these 4% are divided into the peak plasma RNA level. And here is shown the viral kinetics of these 14 post-treatment controllers. If we look a bit more in detail among these post-treatment controllers, their demographics are highlighted here. The majority of them were men, just 1 female. I have just highlighted again that there is a higher chance of achieving post-treatment control if you start on ART early compared to late. We did the same analysis just as I mentioned with different plasma viral load threshold, and it's not surprising that when you increase the threshold, you also increase the proportion of post-treatment controllers. Then we thought, how can we use these proportion of post-treatment controllers? So we did a power calculation to show how many individuals that would be needed if you were to run a new trial tomorrow. So if you did a trial among early ART individuals based on our cohort as reference with 6% post-treatment controller, in your study you aimed at 25 post-treatment controllers. You will in a single arm need 36 individuals, and if you did it as a RCT, you would need 64 plus 64, like 64 in each arm. And again, here, if you're aimed at 35% post-treatment control or 50% treatment control, how many individuals would you need in your trial based on whether it's a single arm or a randomized controlled trial? And the same down here for if it was individuals that were on late ART. So there are still some limitations that I think need to be highlighted. There is some heterogeneity in the ATI studies. There's this time from HIV acquisition. Some of them is based on self-reported. We know that there is a good correlation between self-reported and the analysis of recency, but still there might be an overlap. Also, there's a different time span between the plasma viral load measurements. Even though we had quite stringent criteria that it needed to be a minimum of 5 planned plasma viral load measurement within the first 12 weeks, there are individuals that did it or trials that did it per week, and then trials that did it bi-weekly. And also, again, the restart criteria are different across the trials. And based on that, we might have missed some individuals that would have regained post-treatment control. But again, the higher the peak viral load, the lesser the chance of regaining control. But even though we might have underestimated the frequency of post-treatment control. And again, regarding external validation, all of these trials included in the meta-analysis was done on the Northern Hemisphere, primarily among white men. So it might not apply to every person living with HIV. We have some additional information that I didn't show, but we also did time to viremia with other plasma viral threshold than above 50 copies per ml. We did above 400, we did above 1,000 and above 10,000. And we also did a power calculation based upon time to viremia that I didn't show. And feel free to contact me on my email if you have any comments or questions about the presentation. So a little bit on the perspective. So I just showed you data on post-treatment controllers that the overall frequency is 4%, the frequency among early ART is 6%, and the frequency among late ART is 1%. But from the BNAB trials that has been conducted, the overall frequency of post-BNAB control range from 10 to 20%, and it's higher, again higher among the early ART treated compared to the late ART treated. And in regard to your ongoing BNAB trial, I just wanted to highlight the ECLIS study that we did. So it was an interventional study among newly diagnosed individuals, not individuals started ART during primary infection, but both participants that were started ART early, but also ART late. They were giving, so it's a 4-arm trial, one arm that only received ART, one arm that received ART plus one protein neutralizing antibody, one group that received ART plus a shock drug. I won't go more into detail about that. And then a group that received ART plus the one BNAB and the shock drug. So the BNABs were giving at day, so it's not the long-acting BNABs, so this is like the parental BNABs with a short half-life. So they were giving at day 7 and day 21 after ART initiation. But the main message to take from this ECLIS study is that the virus-specific CD8 T-cell response was higher among after 1 year of ATI among the individuals that received a BNAB. The participants that received a BNAB also had a faster decline in plasma viral load initially and a faster elimination of HIV-infected CD4 positive T cells. And there was a trend towards a larger drop in the size of the reservoir. After 1 year, participants were asked to undergo an ATI, and here's just data shown from the individuals that received a BNAB. Shown in yellow are the individuals that had virus that were resistant to the BNAB, and in blue are the individuals that had virus that were sensitive to the BNAB. And among the sensitive individuals during this 12 week of ATI, 4 out of 5 individuals had either partial or complete control. And actually one individual here at the bottom is still controlling 7 years after pausing ART. My last slide is the acknowledgement. So I would like to thank you for listening and thank you for inviting me at this seminar. And also like to thank the study participant, and I just copy pasted the authors on the ATI paper. And this is like a question slide if there are any questions. Thank you.
Thank you very much, Jesper. So for those in the audience, if you want to ask some questions, please raise your hand. You have the tool in the panel. Otherwise, you can put your question in the chat and we can translate it. Jesper, I had a question regarding what you saw at the end, where or linking your previous study with VNAPs and the data you get from the meta-analysis. You show us all the data about time to rebound and the proportion of post-treatment control. In the study, in your VNAP study, you saw very clearly, and there has been other reports with similar outcomes in the presented in the CROI, where you have people who have a very exponential loss of viral control, very high viral loads, and other people, and in your case, were people receiving the VNAPs mostly, who had a more slow increase and even lower viral loads. And I wanted to know if you had made some estimation of the proportion of people who had this kind of more steady loss of control of viremia and never reach a very high viral loads, even if they don't become post-treatment controllers. How rare are these?
Actually, it's a good question. I haven't looked into this specifically, but I will certainly do it. I think that previously we have mainly focused on whether a participant crosses a line of a threshold, than whether it's a slow or a steep increase in plasma viral load. But I actually think it is important because I think it tells you something about the immune pressure going on during the ATI. So I can't tell you at the moment of the proportion of individuals with a slower increase, both among this ATI cohort, but also among post BNAB participants.
Okay, we have a couple of questions in the chat. So Victor Ape is mentioning whether you had an opportunity to look at the age or gender of the participants on becoming PTCs. I think that for gender, you saw it briefly, perhaps not enough women to take a very solid. But for the age, is there something that can impact the?
No, yeah, we didn't see an effect of age on achieving post-treatment control. And unfortunately, there were too few female participants to really show an effect of sex. But there are some ongoing trials now where the study population is mainly females. So it will be interesting to see this. I did try because there were so there were a few female participants in the entire cohort, but there were one female that was a post-treatment controller. So I actually tried to look at whether there were a higher percentage of females among the post-treatment controllers, but it's still 3%. So 3% of the women achieved a post-treatment control, and 3% of the males. So there were no difference between.
Yeah, and what about the viremia that they reach? Is there a difference between the men and the women, the levels of secondary viremia or post interruption viremia?
Yeah. So there were only one female in the post-treatment controllers that regained control. I can't remember.
No, but
Yeah.
I was more talking in general, whether independently of whether they became post-treatment controls or not, whether viral rebound was similar in men and women.
I think it was, but I know that from an older study, the Spartak study, there were a large proportion of females that controlled for several weeks based on a threshold of 400 copies per ml. Yeah.
Okay, there are a few other questions. So Jerome Stecki is asking whether you have a chance to look at data from immune activation from the studies.
Yeah.
And perhaps related to that, whether you could check the ratio the CD4 CD8 T cell ratio? I think that you saw correlations with nadir and CD4 counts. But...
Yeah, great points, and we would really love to both like look at the reservoir measurements, but among these 24 studies, only half of them did some sort of reservoir assessment, and it's not based on the same method. So it's really difficult to collect all these data and then like combine them. And the same accounts for immune responses, that not every study did it, and it was done in different ways. But I think looking forward that we should gather more, because many of these trials have already collected blood sampling. So it would be nice to gather samples from more studies and then do the same analysis at the same time to see whether it's impacting the viral rebound kinetics. And in regard to the CD8 T cell count, unfortunately, not every trial again has CD8 T cell count as part of their monitoring during ATI. So it's mainly based on plasma viral load, CD4 T cell count, the, the choice of the participants, whether they want to restart or not, but also the investigator of the trial, and like a risk of either SRE acquisition or like spreading infection. So that's the main. So many of the studies don't have CD8 T cell count, unfortunately.
Okay, and for the following question, for the correlations that you observed, was there any differences if you check just the population that of people who were treated late or those who were treated early, or the correlations were similar in both circumstances?
Yeah, I would anticipate that they are similar, but it is perhaps so I don't think any of the correlation are that surprising. I think it's important to look at, like we just discussed, the initial viral doubling time, whether that's like more a marker of immune pressure. I think that's important. But if you look at nadir, that there is a correlation with nadir and time to viremia, it isn't perhaps that surprising, because you would then argue that if you started on art late, that you would have a lower nadir compared to an individual that was starting on art early. So the nadir might be a marker of time point of art initiation.
Mm. And Clotilde Ayavena and Crystal Protier are wondering whether the time on antiretroviral treatment before the interruption had some impact on the outcome after interrupting the treatment.
Yeah, good points. There are coming more data suggesting that the longer time you're on AIT, the more the virus gets, you could say, lock and block, that the virus that's left behind is integrated into genes that isn't very active. I can't give a clear answer in regard to this cohort. I don't think we will see any difference because it's not like beyond 25 years of art treatment. But I actually think we might be able to collect these data from this cohort. So that's something I'm just taking notes to myself. Yeah.
That's good. Another question is by Michaela Müller-Trutun is wondering what happened to the PTCs beyond day 84. Do you have information whether they keep controlling, or do some of them show blips after that time point, or they maintain controlling? Some of them perhaps lose control because perhaps there was the information for some of these individuals.
Yeah, um, some of them lose control, but others control for several weeks. Um, I know that I think it's perhaps from the Visconti cohort that like 25% of post-treatment controllers lose control per year.
Mm. Yeah, not in the Visconti, we don't see 25% losing per year. Perhaps this is from the Jonathan Lee.
Yeah, okay, then it's from
Yeah,
the Chen cohort. Yeah,
yeah. In among the post-treatment controllers
yeah,
during the early time points. In the Visconti, most of them are have been on controlling for longer periods of time, and loss of control is not that frequent. But,
okay, that's great.
um, um, so there is still a couple of other questions. So Caroline Pasas found the association with the NNRTIs interesting, and she's wondering whether there are also correlations with integrase inhibitors, or uh, the duration of the integrase inhibitor. Well, this is closely to what we asked before from early infection. But is this effect that you observe strictly associated with NNRTIs, and do you have any argument about what was the link to this longer time to viral rebound?
Um, we also looked into whether we could see any differences between the whether you were on an integrase or a protease inhibitor, but we couldn't see that it made any differences. It is well known that these NNRTIs have a longer half-life, and the NNRTI treatment at the start of ATI is also mainly from older studies, because the recommendations today are that individuals on NNRTI that's going into treatment interruption, they are at risk of developing resistant mutations. So you would like a minimum of 4 weeks before going into an ATI change the participants' art regime to non-NNRTI.
There's another question about from Jerome Staquier about saying, do you have the means, or the mean time to treatment initiation between the early and the late groups?
The data of the mean so the one we have is based on median time to reaching the threshold of 50 copies per ml, and that was 15 days for late art and 19 days for early art. And if we look at threshold of 10,000 copies per ml, it was 28 days for late art and 38 days for early art. So it is based on the number, it is statistically significant. But I would again argue whether it's clinically relevant that you rebound 4 days or 10 days later.
Yeah, and it's probably shorter than the delay on treatment initiation, probably between these two groups.
Yeah.
And yeah, something that Jerome was also mentioning, and it was visible in your curves with the medians comparing the early and the late treated people. It will seem that early treated people may have had a slightly lower peaks of viremia after the rebound. Is something that you check is statistically significant, or is just an impression because of the median? So.
Yeah, yeah, that's a good point. No, we didn't look into it, but I would also, if you eyeball the data, that it looks like, but I also think that the reason the median curve goes down for the early is also that the longer time you go through the ATI, the fewer individuals
Remain.
are there. Yeah.
Yeah.
So it might be an artifact due to lesser participants. But again, I would argue that if you looked at if the aim of the trial was to have a lower set point, I would argue that again it's better to start out early than out late.
Okay. Thank you. There is a last question by Christelle Protia, but I'm not sure, Christelle, what you are requesting. Is the information regarding the number of studies with ATI that included the initial expected number of participants available? So I know that the list of studies is in your paper, is listed in the paper, but I'm not sure if this is what Christelle was.
Yeah, so the 24 studies that we included are listed in the paper. We also we found additional studies that did fulfill the criteria of plasma viral load monitoring, but some couldn't share the data, and some didn't respond. So it's not a complete data set of all the ATI studies that were done worldwide based on our criteria.
Merci. Thanks a lot. That's the question.
Okay. And so the last question by Pierre Delovelle, and it's again regarding the NNRTIs. It says that the long half-life was mainly for nevirapine or efavirenz, but this is less true for recent molecules such as rilpivirine or doravirine. And he's wondering whether you have some data between comparing all or recent NRTIs or all or recent studies in the difference that you observed.
We haven't looked into it. I don't. I'm afraid that the numbers might get too small, but it's definitely something I'm gonna put on my to-do list. Yeah.
Yeah. No, that could be really useful for new or future studies in people.
Yeah, sure. Yeah.
Okay. Well, I think that that was all. A lot of questions. Thank you all for your participation, and thank you, Jesper, for accepting all these questions, and again for your presentation.
It was delightful. It was a pleasure. Yeah. Thank you.
And we will be in contact, I hope, for future interactions.
Hopefully.
Thank you, Jesper.
Thank you. Bye.
Bye. Thank you all. Bye-bye.
Bye.
Thank you, Jesper, again.
Welcome.
See you soon. Bye-bye.
Yeah, see you.